أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum warahmatullahi wabarakatuh and a very good morning to everyone and hopefully everyone is in apa ni kata good and great feelings good vibes and always in positivity surroundings insyaAllah. So before we start, we will recite a dua. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin Ar-Rahmanir Rahim Maliki Yawmiddin Iyyaka na'budu wa iyyaka nasta'in Ihdinas siratal mustaqim Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin amin. Ya Allah Tuhanku, kurniakan kami kefahaman para Nabi, hafalan para Rasul, ilham para malaikat muqarrabin. Kurniakan kami kecerdasan akal fikiran kami, kecerdasan tubuh badan kami, kurniakan kami ilmu yang bermanfaat. Allahumma inna nas'aluka ilman nafi'a wa rizqan thayyiban wa amalan mutaqabbala. Allahumma inna nas'aluka al-huda والتقى والعفاف والغنى اللهم فقهه في الدين وعلمه التقوى وعلمه الحكمة ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله نبي أمي وعلى آله وصحبه وسلم والحمد لله رب العالمين آمين آمين يا رب العالمين. Okay, today we are going to go learn deeper on how are we going to analyze the beam. Okay, yesterday we have gone through the idea what is beam is all about, where is the location of the beam, how the beam is connected. Okay, what happened if let's say we analyze the beam or we design the beam in a wrongly manner? What is the output? Okay, what is the condition of the beam if you have a weak beam? Right, so we have exposed to you yesterday on how the beam looks like. Okay, so when you understand the outcome of not having a good design, not having a good analysis, hopefully you inspire, okay, to learn more how we want to design or how we are going to analyze in this class. We are not going to design, we are going to analyze the beam in a rightly manner. Okay, but before we go further, we must understand first, okay, what are the components, what are the features that we need to know in order we analyze the beam. Okay, so first of all, we need to understand first, okay, the functionality and the purpose of having the beam analysis. Okay, we want to see the functionality, the purpose, why we need to analyze the beam. Okay, what is the function of having the beam analysis? The second one, we want to see what are the things that contributes. Okay, what are the things that contributes the beam? Okay, the beam to happen like yesterday's failure in beam, the mechanism, how it will looks like, what are the things that it will interfere. So we want to see the types of loading. We want to see the types of support. Does the type of support influence the beam analysis ataupun the beam behavior? And we want to see the internal forces in beam. Does the internal forces in beam influence the beam analysis? And the difference between internal forces and also type of loading. Type of loading is actually focusing on the external loading, right? Whereby in the internal forces, you will be experienced. Before this, I have shared with you, internal forces will experience due to your ataupun will be contributed by these supports. Okay, support system, your support system. And lastly, what is the why we need to do the beam analysis actually at the end of the topic. Okay, the student should acquire how to transpire the bending moment in beam and also shear in beam. Okay, so we want to see the connection between these two. Okay, what is the connection? Why is so important? Right, this is actually the most important part in beam analysis. Why is so important? All right, in order for us to before we proceed with design beam in beam analysis. Okay, let us see the functionality, the purpose of beam analysis. Okay, first, the purpose. Okay, we want to analyze the beam is to check the stability of the component. Okay, the stability of beam. Okay, due to what? Due to loading. Okay, loading what? Loading external loading, internal loading. Okay, I want to check the stability of beam due to the support system. Okay, does the support system, if let's say we use this type of support, does it affect the stability of beam? Okay, and then we want to see, right, when we have these two bunch of mechanism of loading and support in a system, right, we want to see the behavior of the beam. Okay, so other words, the function of having the beam analysis is actually to check the stability, number one, and number two, we want to see the behavior of the beam based on the based on what? We want to see ultimately we want to see the behavior based on the bending moment behavior, right? Bending moment behavior and also shear force behavior, because these two, right, these two will give you some ideas the behavior of your beam, right? The behavior of your beam, how the beam will behave with this kind of loading, with this kind of support. All right, does it stable at the end of the day? Does it stable or not? Okay, how are you going to check whether it's stable or not? So you have to do the extra extended analysis, which is you are not going to learn this extended analysis. You are going to learn this extended analysis in future in structural analysis classes. Right, you want to check based on the deflection. Okay, the deflection of the beam, right, with correspondence to your provisional standards. Okay, in our case, right, what does Eurocode says? Eurocode is our provisional standard. What does Eurocode says in terms of deflection? Okay, what is the reasonable? Okay, what is the allowable deflection for a beam? Let's say it's 2 millimeter. So does the extended analysis in future later on, do you get 2 millimeter? Or you get more than that? Maybe you get 5 millimeter. Okay, if let's say you get 5 millimeter in your analysis, then you compare with the provisional code based on Eurocode is 2 millimeter. So this is larger than 2 millimeter from the Eurocode. Okay, meaning that the beam is unstable. Okay, due to the deflection. Okay, exceeds the provisional standards in the Eurocode. Okay, so here I want to highlight again the purpose or the functionality of having the beam analysis is actually to check the stability. Okay, number two, we want to see the behavior of the beam, whether the behavior of the beam will give us stability mode or unstable mode. Okay, next. Okay, the next one, you want to see what is the internal forces in the member. Okay, internal forces in the member. Previously, we know that internal forces okay, will directly contribute by your support. Okay, today we are going to learn your internal forces. Okay, or internal forces, okay, in member. Last time we have learned on the support system. We know that if let's say it's fixed support, okay, let's say saya ada fixed supports. So fixed support ada berapa internal forces? Okay, right, 1, 2, 3. Kan? Ingat tak yang ni? And then let's say I have a pin. Okay, I have a pin member. How many internal forces that I have? 1, 2. So I have 2 internal forces. And let's say I have a roller support. So roller support, how many internal forces you have? Only 1. Okay, only 1. So now we are going to see your member. Internal forces that comes from your member. Okay, last time we see the internal forces from your support. Okay, right now in beam, okay, beam. So yesterday I exposed to you your beam. It can be in a straight prismatic member beam. Okay, it can be a diagonal member. Okay, or it can be a curved member of beam. Okay, yesterday I've shown to you. So whether it's straight, okay, inclined or diagonal, okay, or a curved beam. Okay, right? Clear, yeah? Alright. So we already know that beam also, the shape of a beam can be, okay, it can be a square, it can be round beam, okay, or it can be an I-beam. So yesterday I showed to you the hexagon beam from the steel member. Remember that? Okay, so it can be in that manner. So normally, okay, shape type of beam, then normally throughout the section, okay, okay, normally, normal circumstances, throughout the section, normally you have one type of material, okay, one type of material. Apa maksud one type of material? Okay, maksudnya shape, one size, okay, and normally you have one shape. Okay, when you have one type of material, when you have a one type of shape, we call this as a prismatic member. Call it as a prismatic member. Okay, these are the introduction physically how the beam looks like. Okay, physically how the beam looks like. Okay, right? Okay, now what happened? Okay, let's say, okay, what happened? Okay, we are going to focus now more on the internal forces in member. Okay, right. Now I just choose one type of member of beam, which is a straight beam. Okay, it's a square in shape, okay, of the cross section. Okay, and then I have one material, let's say it's a reinforcement concrete beam, RC beam. Okay, and it's a straight beam. Okay, lagi apa lagi? Straight beam, prismatic, lagi apa material dia dah letak, shape dah settle. Okay, now settle. It's a square beam. Okay, so yang ni kita kata prismatic beam. Now beam, okay, now We want to know more about internal forces in member. Bila dia kata member, so from here to here, saya ada satu member. Okay. Let's say I have a continuous beam. Okay. Sambung. Okay. Kalau yesterday tu, kalau you tengok semalam, saya ada tunjuk dekat you steel framing steel. Okay. So yang ni kita panggil dia sebagai, we call this beam, this kind of beam connected macam ni. Okay. Kita panggil dia sebagai kita panggil dia sebagai continuous beam. Okay. Continuous beam. Bersambung. Okay. Kalau ada satu member ni, kita panggil dia only a single beam. Okay, now. Kita tahu, kita dah belajar dah previously, connection. Okay. Contoh. Okay. The connection here. Okay. The connection here, it can be either, okay, fixed ataupun pin. Can be either. Okay. Fix ataupun pin. Okay. Kalau fix pin. Okay. Kalau fix pin member, support. See this connected. Okay. Connection. Fix pin connection. Right. Maknanya kalau fix connection ada berapa? Internal forces ada 3. Ingat tak? So let's say this is fixed. Okay. Kalau this is fixed, maksudnya dia akan ada berapa? Okay. Kalau dekat sini, dia ada berapa? Okay. Kalau dekat sini fixed, let's see ya. Okay. Saya tulis baru ya. 1, 2, 3. Okay. If it's fixed. Okay. Kalau yang ni fixed. Okay. Alright. If let's say this one, okay, spin. Okay. Maksudnya dekat situ saya ada berapa internal forces dekat that support pula connection. Saya ada 1. Lepas tu saya ada 2. Ada 2. Sini ada 3 sebab dia fix. Sini 2 sebab dia pin. So ini kita panggil dia support. Sorry, not support. Connection sebab dia connect to each other. So this is connection. Okay, connection. Right? Clear eh? Okay. If let's say single member saya ni ada support. Pin, support saya kat sini, roller. Okay, roller. Bermaksudnya dekat sini saya punya internal support saya ada berapa? 2. Betul tak? Ni roller ada 1. Okay. So apa yang saya cerita ni, internal forces bukan dalam member, internal forces di dalam connection and also support. Okay. Connection dengan support. Okay. 2 perkara yang berbeza. And berbeza untuk internal forces in member. Okay. Yang saya cerita tadi dekat connection dengan support. Now saya nak cerita member. Kalau di dalam member, let's say I'm using a single one, straight one. Okay. Di dalam member sebenarnya kalau you nak tahu internal member, dia, you kena cut the section. Cut the section. Cut the section. Cut the section. You kena cut. You have to cut the section baru you dapat internal member. Okay. What happen kalau saya consider cut section dekat sini? Okay, contoh. So, bila saya cut, automatically saya ada left hand side section and saya ada right hand side section. Okay, so kalau saya lukis, dia akan jadi macam ni. Okay, katalah this point is point A. Okay, so nama dia, cut dia akan nama cut AA section. Okay, in engineering drawings ataupun in architectural drawings selalu ada cut section. Sebab dia nak tengok cut section tu macam mana rupa dia. Okay, so bila you cut your section, okay, automatically you kan ada internal forces. Okay, internal forces. Okay, bila you cut your section, internal forces. Okay, kat sini akan ada internal forces. Okay, clear Clear, ni yang paling penting sekali untuk internal member. Tak kisahlah dekat mana section cutting, right, dia mesti ada internal forces. Okay, let us see macam mana internal forces looks like. Okay, how internal forces looks like. Okay, saya lukis balik. So let's say, right, let's say this is my beam tadi. And then saya cut section dekat sini. So automatically bila cut, okay, dia akan ada remaining one. Okay, the left hand side, the right hand side section. Okay, right? Okay, now let us focus. Okay, let us focus dekat sini dulu. Okay, so bila saya cut section saya, okay, bila saya cut, automatically saya akan ada satu force, dua force, okay, tiga force. Bila saya cut, okay, force yang pertama yang kat sini namanya vertical force. Vertical kan, sebab apa vertical? Sebab dia going up, okay, vertically. Okay, nama dia selain daripada vertical force, kita panggil dia shear force. Okay, got it? Okay, shear force. Yang kedua, saya pakai color lain Yang kedua, the one that is perpendicular to your section. Okay, yang ni kita panggil dia horizontal force. Nama lain untuk horizontal force kita panggil dia normal force. Normal force. Okay, clear Okay. The next one yang kita ada, this one yang saya cakap nombor 3 ni, nama dia M, moment. Okay, moment. So you ada shear force. So you ada shear force. You ada normal force. You ada moment. Selalunya your horizontal force ni kita tak panggil dia, kita tak notify dia as H. Kita selalu notify dia sebagai N. Right? Kalau you tengok dekat dalam buku, sometimes dia letak F. Okay? F. Okay? Maksudnya force lah. Okay? Maksudnya force. Right? Clear So dia mesti ada 3. Okay? Mesti ada 3. 3 apa? Kena ada 3 internal force. So these 3 is called internal force in member. Okay? Okay? Clear So saya dah lukis dah tadi. So saya nak tunjuk you lagi satu sebelah dia pula. Tadi kita tunjuk yang ni tadi. Okay. So what I do is buat macam ni. Saya padam ni. Okay. So now kita tengok yang sebelah dia pula. Okay. The other side pula yang sebelah ni. Okay. Saya nak tengok sebelah ni pula. Okay. Right. Okay. Saya padam ni. So, internal forces for the right hand side. Okay. The right hand side ni sama tak? Ada 3 tak? 3 internal forces ke? Sama, dia ada 3 juga. Okay. So, saya lukis kat atas. Okay. Saya lukis kat atas. Okay. So, saya ada 3. Same one. Okay. Saya ada, bukan color lain. Saya ada shear force V. Shear force. Saya ada normal force which is dia mesti apa? Perpendicular. Saya panggil ni normal force. Which is kita selalu notify dia sebagai N. Okay. And last kali kita ada apa? Kita ada moment. Kita ada moment. Selalunya kita notify dia sebagai M. Okay. M. So this also kita panggil dia sebagai internal force in member. Internal forces in member. Okay. Alright. Sama juga ada. Okay. Apa beza antara dua tu? What's the difference between these two? Apa beza dia? Okay. Beza right hand side dengan left hand side. Beza dia adalah plus ataupun minus. Positive ataupun negative values. Okay. So selalunya kita set going up is positive. Follow the direction of X direction is positive. Okay. And then lagi satu, kalau clockwise, kita consider dia positive. So yang ini kita panggil dia sebagai positive force. Ataupun positive internal forces. Okay, clockwise. Opposite than that, maknanya kalau dia going down, opposite to X direction, and then the anti-clockwise, kita panggil dia sebagai negative forces. Okay, cuba kita identify mana satu positif, mana satu negatif. Okay, kalau tengok yang ni, kalau tengok left hand side, so going up, okay, going up, positif. So, kita akan jadikan dia V positif. Okay. So, kalau kita set yang ni going to this direction. Okay. Going to this direction. Positif ke negatif? Kalau kita follow yang ni. Set yang kita set. Dia akan jadi negative. So negative N. Contoh. Okay, negative N. Tadi kita dapat positive V. Kalau moment, dia clockwise ke anti-clockwise? So dia anti-clockwise. So anti-clockwise dia jadi negatif. So dia jadi negative M. Okay. Kalau tengok shear going up. Oops. So shear going up. Contoh, kita set up. Positif ke negatif? Positif. Yang ni ikut follow X direction. Positif. Positif N. Okay, positif V. Moment clockwise akan jadi positif. Okay. Tapi setting dia macam tu ke? Setting dia bukan macam tu. Setting dia akan jadi macam ni. Okay. Kita tahu. Sekejap. Okay. So at the end of the day. Alright. Bila kita draw. Okay. Okay. So internal forces in member will looks like this. Okay. Going up. Kalau left hand, this is left hand side. This is right hand side. Okay. Kalau ni sebelah left going up. Yang ni akan going down. See opposite direction opposite. Kalau yang ni going in. Yang ni saya buat color lain. So that you can differentiate. Okay. Kalau yang ni going into that direction. Yang ni akan going into that direction. Okay. If let's say saya punya moment going this direction. Right. Anti-clockwise. This one gonna be clockwise. Okay. Dia mesti macam tu. Okay. Right. Kalau saya draw balik, yang ni akan jadi moment. Yang ni also moment. So kalau you set going up clockwise positive, anti-clockwise negative, going down, going to this direction, negative. Kalau you set macam ni. So automatically kalau anti-clockwise, dia akan jadi negative, clockwise akan jadi positive. And then kita nak tengok, okay, kalau normal force going into that direction, same with this one, gonna be negative. Follow the direction of that, dia akan jadi positive. Sebab dia ikut X direction. Okay. And lastly, you ada shear force. Oops. Okay. You have shear force going up. Yang ni, that is positive. So V, positive. And then you ada V going down, negative. Dia akan jadi V, negative. Okay. So this is the most important section yang you kena hadam berkali-kali to differentiate, to find the forces in the internal member. If let's say you considering the analysis on the left hand side. So inilah dia punya formula dia. If let's say you are considering right hand side. Okay. You are considering right hand side. So these are the rules that you have to follow. Alright. Okay. So kita stop for a while for 2 to 3 minutes. Then insyaAllah kita akan continue again to the next session. Okay. Thank you. Assalamualaikum. See you back in 5 minutes.